Hello, and welcome back to Having Fun Repairs. What I have in my hand is an old LG V20, and I still use this phone for a lot of things. Primarily, I use this phone specifically for work as a way for people to contact me. Uh, and I've been having an issue with it where the audio is dropping out. You can kind of hear that right now where I have a frequency generator set in here, or application, to produce the tone out of the speaker, and the audio itself just cut out. And if I was to take and put pressure down at the bottom, you'll hear that audio come back in and then fade back out. Now, suffice to say, this isn't the first time I've been into this phone. Free applications. Um, and what I did previously was put a little solder bead down on the connectors. They compress together. They're not a hard connection. Just so I can make contact. And over time, through vibration with the speaker itself, those solder points are probably wearing down, and there's less because there's not a substantial amount of force holding them together. It's probably just that slight mechanical connection is wearing down. So I need to find a more permanent fix. But I figured now's the time to take apart this phone, see if I can make a more permanent fix, but also teach some things about audio and how to use an oscilloscope to look at an audio signal. So what I'm going to do is I'm going to play this 450 hertz tone again, and I'm going to plug in a phono plug in as if I was going to listen to this out of a headset. And then on the other side, I'm going to take a probe that's going to be connected to my oscilloscope and put one side on ground and then the other side on the tip, so that way we can see that signal as it comes up on my oscilloscope. Now give me a second as I pause the video and reposition what I'm recording from, so that way you can see exactly what I hope to demonstrate to you on my oscilloscope. Alright, so first off, I have my oscilloscope set up, channel 1, coupling set to AC so I can see an AC signal and take measurements thereby of that AC signal. And then again, my ground probe is going to go to the ground part of this phono plug, and then I can connect this to the top pin, and you can see an AC waveform set up. Now my volts per division is set up to 200 millivolts. I can increase that or decrease that. My time per division is set up to 500 microseconds. Additionally, my phone is outputting that 450 hertz signal, but it might not be at the max for the audio out. As you can see, I can increase and decrease the audio. And I want to show you a couple things that happens when I do that while this is connected. And I'll move my hands out of the way. So when you see something pop up on the oscilloscope, that is the actual audio that's coming out of this phono plug. Okay, and I want to show you a couple things. This sine wave represents my 450 hertz signal. Now I can increase the frequency, and when I do, you'll see that sine wave comes closer together, and as I decrease it, it'll make a corresponding change when it comes further apart. So frequency, first off, is the inverse of time. Let me go back to my 450 hertz signal. 450 next. Okay. And so what I can do is I can have my cursor selected up. Actually, before we get into time, the speaker itself, there's circuitry in there to increase the audio out, some type of amplification circuitry. So as I increase the volume you'll see that the amplitude of my sine wave also increases. And as I decrease the volume out, you'll see that it decreases. Now I'm going to set this to maximum volume out, okay? Because I think that would be a good baseline to see if this fix actually worked. Again, the audio is right now is coming through the phono jack, not the speaker. The phono jack comes before the speaker. The issue is not with the phono jack. The issue is specifically with the speaker that's in line with that circuitry. Now, if I go to my cursors, say I want to take cursor A and I want to set it in the middle of this first peak, about right there. And cursor B, I'm going to do about the same. Okay, and this is more or less an eyeball, but you can see up here in the upper left hand corner, I'm getting 2.22 milliseconds. Now, this oscilloscope automatically calculates out where my cursor is set and tells me that I'm seeing a 450.4 hertz signal. As I'm, just eyeballing this, that could be relative to where I have my cursors in line at. It could also be that the frequency that's being generated is not quite as accurate as I want it to be. Now, if I change my horizontal controls, I can actually, and that's going to be too much for me to take an accurate measurement. So I think I'm just going to leave it there. I could also change the volts per division. Gives me, and see, the amplitude hasn't changed based off of the output. That's just me changing on my oscilloscope so I can see a better signal. Let me go back to cursor A. I'm going to put that right in that peak. And cursor B, put it right towards that peak right there. All right, again, 2.22 milliseconds. Now I could do this math myself if I wanted to, which I'll demonstrate on my phone. So just bringing up my calculator, if I take the inverse of that, of the time between the fall time to the rise time to complete one full revolution or one full cycle. So I take 1, and then I'm going to divide it by 0.00222, or 1 divided by 2.22 milliseconds. And what is that going to come out to? That brings me right to 450.45 hertz, which is also what I'm seeing here. I also want to take note of the actual amplitude of my signal. Now, when I'm looking at this AC waveform being produced by my phone, one thing I'm going to look at is the characteristics of this AC waveform as well, to make sure there's not a lot of spurious emissions or jagged indications. I mean, this is the signal itself. It doesn't look too dirty to me. That looks like a fairly good AC signal. This is an older phone, so the actual headphone jack in it could be dirty as well, which could be an indication of that. That's something I could clean. I also want to measure the amplitude of this. Voltage, Vmax, okay. Let's go to my all measurements menu. I'm going to turn voltage on. Alright, so my voltage peak to peak is really what I'm concerned with, because we're looking at a AC signal. It's got a volt peak to peak of 808 millivolts. Another important voltage to look at would be volts RMS. That's your true AC voltage. So RMS stands for root mean squared. So here we're getting 2.27. So that would be two references that I would write down. And then I'm going to come back to and see if there's been any change with the permanent fix. So peak to peak, 808 millivolts, and volts RMS, it's 272 millivolts, and those would be millivolts AC. Okay, so I've taken a reference, I've looked at my AC waveform. The output of it is around 450 hertz. Exactly what I was hoping to see produced by the application. I've got the volume adjusted for my phone at max, so this will help me ensure that I'm using the a good reference, because I'm not middle of the range on my volume adjustment. I'm not all the way down to where I'm not going to see anything. I keep it as max as possible. So this is my reference point. Then after the repair, I will check everything based off of the same frequency, 450 hertz output, volume adjustment for the headphone jack out at max, and just see what occurs. All right. The next thing I'm going to do is tear down this cell phone. Now I'm not going to video record this. I think you could figure out how to tear down the cell phone yourself. There's plenty of videos for that. But I do want to tear down the cell phone and just show you and then go over the parts and take you all along with me, trying to figure out how to have a permanent repair to the speaker out on this, so the audio is not dropping out when I'm using the actual speaker. Alright, so I've got the entire phone disassembled right now. Well, not completely disassembled, but disassembled enough to get to work on some things. Here goes the main back piece beyond the actual cover itself. You got some bezels at the bottom and the top that had to come off, and then this could get freed up and come out. This corresponds to your camera lens cover, which has a crack in it. Like I said, this is a very old phone that I still use today. I just don't want to give up on it yet. The bottom half looks pretty decent. But this gets into, here's the actual speaker module I was mentioning earlier. And this speaker module actually, I think at one point in time was a part of this plastic right here versus separate from it, but maybe it broke loose from here. But regardless, like, this phone is always with me in conditions that are really not preferable for it. And I'll explain why. Let's zoom in a little bit. So where this speaker module actually sits, you can see a solder point here where I place in some solder, and then a smaller one down in the corner there. And what this lays on, these 2 points right here. And so when this bezel is screwed down like this, it actually applies pressure on those points to make that mechanical connection. But as I've had this phone near areas that produce a lot of steam, near water and stuff, you can see that there's been a lot of corrosion in here, and I've really just been putting it off a permanent fix. I can also tell you that prolonged use with this phone, it begins to generate a lot of heat, especially towards the top where your main processors and more intelligent devices are at. You can see kind of a nice layer of film that's beginning to show on top of some of these shields near the processors. It's possible with these caps that are on here that maybe there's just a nice film on this that is accrued on it, that's kind of turned those caps more into act more like resistors and capacitors. A way that you could get rid of without actually having to bust these or break these covers off and provide a better heat sink, maybe a thermal paste underneath, is actually just cleaning up everything first with a little bit of vinegar. That will get rid of anything that's eating away at the board, especially corrosion, I'm going to put some vinegar down here and let it sit for a minute to eat most of that away. And then after you give it a nice vinegar bath, then you need to make sure that you thoroughly dry and give it an isopropyl alcohol bath as well. Put quite a bit of IPA on there. So I think that's what I'm going to do first before I actually get into trying to figure out how to permanently affix or repair that speaker. Zoom out for a second. So what I'm going to do, obviously my battery's not plugged in, got everything fully disconnected. So I'm going to get some distilled vinegar down in here to start, and it will start to bubble. You might be able to tell via the camera itself, I'm not too sure, but this area down in here is starting to bubble up a bit. Again, like I said, it's an old phone. I don't want to get rid of it. It's worked really nice for me for a very long time. I'm going to keep it until it's absolutely dead, and who knows, maybe what I'm doing right now is actually going to cause a bigger issue than what I'm hoping, than just repairing it. But regardless, I mean, I'm going to clean this up as best as I can, get it thoroughly dry afterwards. Just make sure that there's no corrosion on parts that doesn't need it. Let it sit in this vinegar for a little bit and then clean it up with some IPA afterwards. IPA is going to do two things, because vinegar isn't going to dry up as quickly. You can already see some bubbling up here in the upper right hand corner, which tells me that there's been some corrosion. The IPA is going to wash out any remaining vinegar, and it's also going to dry up a lot quicker as it evaporates. But this should give me the best results when it comes to cleaning. Again, I have everything on an ESD mat as well. My ESD mat has a ground point tied to it in the right hand corner, and then a clip that goes off to a ground. So I don't want to play with this thing. If I was, I really do want to be concerned about electrostatic discharge, to be honest. Especially with a device that's such as this, is definitively going to have components that are very ESD sensitive. I don't want to damage them with anything that I'm doing. Even using these cotton buds and stuff like that. If I wasn't on an ESD safe mat, and if I wasn't grounded myself through a wrist strap, I mean, it might be overprotection at this point based off of having this on a mat itself, but it could damage this device more, and that's something I adamantly want to ensure I'm not incurring myself. Alright, so you see what I'm doing. I'm now going to stop the video and just get this thing cleaned up as best as I possibly can. First, via cleaning with distilled white vinegar, and then cleaning afterwards with isopropyl alcohol. Okay, I've gotten this cleaned up quite a bit, and I actually went in and took the board physically off of the housing. On the back side, there was heatsink compound going between this copper plate and here. That was pretty dried up, so I'm going to replace that heatsink compound with fresh compound. One of the things that occurred while cleaning, and I had a feeling it was going to happen, is you can see in this upper right hand corner, or excuse me, left hand corner, there are these metal tabs, and they actually compress a little bit. There's one that went missing here. Now, I'm not too sure what that's for, if it's for maybe an antenna for Bluetooth or maybe Wi-Fi, maybe cell phone reception. Here's the top bezel. I'd have to look it up to say the least. But the metal connector is up there, so I do know that there needs to be some form of contact. It says V, so maybe, typically when I see V, I think a voltage of sorts, but that might not be the case. It could be corresponding to something else. Again, I'd have to look it up. I don't know off the top of my head. These are things that I would typically look up. But what I would like to do is try. I lost that little piece, but there's a bit of copper here where the metal, where the little device was physically attached. Let's see if it'll focus for a second. Focus, 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 focus. There we go. So right here is just a wee bit of copper, and what I'm going to try to do is put some paste flux down on that, and then with a little bit of braided copper that you typically use for cleaning up or de-wicking, getting rid of solder. So I'm going to use it to make a plate from that here to there, and then build up a little bit of rosin core solder on top of it to a point, and hopefully to reestablish that one physical connection. So in order to do that, the first thing I need to do is get a little bit of paste flux physically on that point, and then hopefully any solder I put down on that point, hopefully it will adhere. So I'm going to put this down on my table, and I typically wouldn't solder directly onto an ESD mat. I would have this in some type of jig to do that. I don't want to ruin my ESD mat by soldering on it. But as I'm recording this, and I'm using my jig to hold my cell phone, it might not be able to do it in this instance. All right, so put a little bit of solder on the tip of my soldering iron, and forgive me if I get in the way of this, but I've got to get really close to see what I'm doing. Okay, so I put a little bit of solder down, and you can see where it's running between that connection up to there. And that should make this a little bit easier, so I'm going to clean it up real quick. A little bit of alcohol and my brush. Get rid of all that flux that was just laid down. Let's see if I got a brush this home scrub a little bit harder, a little bit more coarse than that one. Alright, now what I'm going to do is try to trim this to size, because it's going to become the new bottom plate that I'll build off of. And that is relatively way bigger than, say, this one right beside it. Alright, so what I'm going to do is pause the video. I'm going to cut this wire copper mesh up a bit and get it ready for soldering into place. Okay, I've got it cut, and it's going to become a new pad. So let's see if I can get it to there we go. Got to make a connection. So now let's take a look at this. Alright, so that is in place, and I think it looks relatively good. It looks atrocious on the camera, I get that. The point is trying to see if I can't build something here, and I just broke it off. Okay, live you learn. We'll try it again. See if I can't expose more copper and get it onto there again. Alright, so what I've done since stopping the video is I put a very small strand of well, I took my multimeter and I went from the pad that was over here to these little points over here, and I got continuity. I believe they're right in line. There's a cap out here that I'm not connected to, a very small cap. It's just the small test points immediately beside it. I ran a very small fine piece of copper from this point all the way to where the plate was at. And then after I soldered that small piece of copper in, then I took that original rectangle piece of copper and I soldered it, put down a bead of solder and heated it up and pressed it onto the wires and check for continuity. Then after that I took another small piece of copper and some lead solder to build up on this point. Now it's not exactly at the same distance from the board as this piece right here, as this connector here, but the connector is designed to flex down once it's pressed up inside the upper bezel. Not this one, that's the bottom bezel, this one right here. And so what I did is I went ahead and took the bezel and placed it over both those points, and then applied a bit of pressure down to gauge to see if it's going to connect. And it looks like it's making it's touching. Both metal tabs in here are touching decently with both pieces there. So now it's going to be, how do I make a permanent connection between this speaker and these two posts down here? Now I've already have some solder on both of these, and this is plastic, so this is very hard to work around. I will melt this if I'm not careful. But I'm thinking, since I already have some lead solder down on those posts and down on the speaker, that quite possibly, let's see, posts are here and here, quite possibly I can lay this down. I might have to build up the solder a little bit more on each post. Let me get back over here. But quite possibly I can use a fine tip on my soldering iron and just get some heat at these points, and enough to melt the solder and then press and make that physical connection. I think that's what I'm going to do now. I'm going to add a little bit of extra solder to these posts to build it up a little bit, and then put this on here. If you'll focus. Come on. Focus, 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 focus. There we go. Put a little bit of solder on each one of these posts to build them up a little bit. And my kids are awake from their nap, so you're probably gonna hear them from the background. But afterwards, I'll press this up to here, take the fine tip of my soldering iron, put it at each spot to see if I can't get the solder to melt, and press them into place. Okay, so let me zoom in just a little bit. Alright, got that built up some. So now when I put the board this way, you're going to see that I have peaks on both of these points. That's what I meant by building it up. A peak right here, and then a peak right here. So now when I press this to there, if I get enough heat on those points, I should be able to press this board down and get it into place. Hopefully this will work. I'm going to have to go off camera to do this because I'm going to have to put my eye on it in order to make sure I don't mess this up. So I do want to apologize that I can't show you this on camera, but you should see the finished result. Alright, so something that helped me out is this is a speaker, so there's a magnet in it. So I was able to lay the board underneath, lay the board onto a metal surface similar to, a metal surface, similar to the orientation that I'm holding it right now. So the board effectively being underneath these the upper soldering points. So as the speaker, the magnet in the speaker was pulled towards that metal surface, it was actually holding this entire board in place. And then I just used a fine tip on my soldering iron here. Mine's just a little dirty because I did melt some of the plastic. And then I heated up the solder that I put on the board and was able to make it establish a connection with the solder I'd put on the speaker itself. So you can see that both here, physical connection on this side of the speaker, and here as well. It's not perfectly flush by any means, but I don't think that's going to matter in the long term. So what I'm going to do now is try to button this back up to see how everything fits together, and test it out to see if it's working. If not, we're going to pull this all back apart. But I'll put some thermal compound on the side of this copper plate here, and so when it compresses, it will still have heat transfer to this metal plate here. Get it all buttoned up, put back together, and we'll test it out to see how everything works. Okay, so I've got the phone back together. I'm going to put my battery in and we'll turn it on. See if that fixed it, or maybe if I made it worse, and we'll check out to make sure that Bluetooth still works, Wi-Fi still works. Everything you'd expect of a phone to work to still be working. Alright, this phone's turning on. Kids are eating dinner right now. I had to take a short break to get that ready. Alright. I don't know if you heard that, but
Daddy, there's rats in our house.
I hear you, buddy. We'll get it in a second, okay? Alright. So, I'm getting cell phone reception, and I'm connected to Wi-Fi. Let's turn up the volume. Sounds like the volume's working. Turn down. Let's turn it back up. Alright, let's go to that frequency generator. Sounds like it's working just fine. Is the headphones still turn on?
Daddy.
Alright.
I killed the fly.
You did a good job, Ollie. So, if it will focus, you'd be able to see it. But, here, maybe if I exit out. Headphone icon came up. Unplug it. Disappears. And with it plugged in, I'll take a look at with my oscilloscope, verify if we're at around the same levels that we were looking at previously. Okay, I've got the output of this phono plug here, hooked up to my probe. And then what did we have previously? We had 808 millivolts AC and 272 millivolts AC. Well, 808 peak to peak and 272 millivolts AC. Volts RMS, that is. So, still getting 808 bouncing 816. The fact it's going higher tells me that there's probably better connectivity. The actual AC measurement that we're getting on this 450 hertz sine wave is 280 volts RMS, slightly higher as well than what it previously was. Just going to make sure that I've got the volume turned all the way up on my phone. Give me 1 second. Okay, the volume is turned all the way up. Oh, losing my grip on the probe. There we go. Yeah, volume is all the way up. If I turn the volume down a little bit, you'll see the amplitude of that speaker audio decrease. And again, if I increase the frequency, you'll see the corresponding increase on my oscilloscope. 450 hertz. Alright, so I would say that hopefully this is a longer lasting repair on my LG V20. I'll turn all those measurements off. Go out of my cursor A. Put it at that peak. Cursor B. Got it just slightly before the peak there and there. 448.4 hertz. Around closest you're probably going to get with this type of oscilloscope to 450 hertz measurement. Alright, we're going to call this a successful repair. And hopefully it lasts a lot longer than the previous ones have. And I hope you enjoyed the video and learned a little bit of something. And have a good day.